Actually, while we're waiting for everybody, how many people in here are currently majoring in or are planning to major in or have a degree in computer science or computer engineering? Okay, so most of the room. How many people don't? What kind of majors do we have in the rest of the room? Or careers, or? I know I have a food engineer, which I still think is like the coolest major ever. Anybody else? Just feel free to like shout it out. Chemical engineer. Very cool. Industrial engineer. Awesome. Any others? What? Automatical engineer. What do you do with an automatic? Oh, mathematical. Okay. It's like automatical. Is that like cars or automated processes? I don't know. Each place. Anybody else? Other things? How many people are still in school? Oh, we have one in the middle. Okay, I cannot hear you. Sorry. Food engineer. Oh my goodness, we have 2 food engineers. That's really, really cool. I wish we were doing that right now. Anybody else? How many people are still in school? Cool. And how many people are out of school? Everybody else? How many people are neither in school nor out of school? True question. Okay, cool. All right, well, why don't we get started? And as people file in, that's totally cool. If you have any questions during the presentation, feel free to just jump in. It's totally fine. So I'm going to go through a lot of different features of AppEngine, and if you have questions on any piece, just raise your hand, shout out. It's cool. And at the very end, we'll do some questions about both AppEngine and any questions you might have. Engineering, Google, being a woman engineer, whatever you want. So I'm going to talk about Google AppEngine and a little bit about the cloud. But first, let me introduce myself. So I'm Sonny. I'm from the Munich office of Google. I originally actually worked in New York, so I put a nice little picture of New York skyline over here. I grew up in Maryland. How many people know where Maryland is? It's kind of tiny. It's right near Washington, D.C. Very good, actually. I saw a few hands. And we eat lots of crabs, so I have a picture of crabs. That's our one thing that's awesome about us. There's a few others. I live in Munich, so I have my picture of my Oktoberfest picture as necessary. I have a ton of hobbies. I couldn't really fit them all on this slide, so what can I say? So I did martial arts. I'm really into sewing. I'm also really into sailing. You can kind of see me up there sailing. I'm actually in front of the Statue of Liberty. Sort of a shame that the statue is not in the picture, but I promise it's there. And that's my team right in the middle. So that's my team in Munich. We're getting kind of big, so it's pretty cool. So what I'm going to talk about a little bit is first what cloud computing is, and then we'll talk a little bit about AppEngine and different features that AppEngine offers you. Some of these features are not strictly AppEngine. Some of them are just Google Cloud Computing in general. If you guys went to the earlier presentation on Google Cloud, you may have some overlap, but not completely. And then we'll have some time for questions. So typical app development. How many people develop web apps or have developed web apps? So web app development can be very complicated, right? So you have a ton of different moving pieces. So a typical web development might be on like a LAMP stack. You have a bunch of machines, and usually you start out with one machine, right? Because your app is kind of small. And then eventually you start getting users, hopefully. And then suddenly you need 2 machines, and then you need 3 machines. And then you end up being Google, and you have billions of machines worldwide. And so you start trying to scale up. And then you're probably going to have a database, right? And you have your database, and then, again, how do you split that then when you have more than one machine? And so then you have to sort of load balance, and you have to split your data up, and then you want to shard it maybe, because maybe you want to be worldwide. And it gets complicated really quickly. Because all of those machines, you have to start allocating, you have to stick them in different locations and stuff. So that brings into cloud computing. So how many people know what cloud computing is? Can somebody tell me? Somebody want to tell me what cloud computing is? Sure.
I think it is a new way of marketing the pre-existing mainframe servers. So personally, I don't believe in cloud computing. It's an already existing technology, which has been now lately marketed as a new piece of work.
Sure. So it's a bit of a marketing term these days. I got that. But what does it mean? So when we say cloud computing, what do we mean by that?
You can say we are developing the application and it's running on cloud this application on the cloud?
Sure. Absolutely. So yeah, so to sort of repeat that, since you didn't have a microphone for most of that, you sort of have an application and it's running on a bunch of different machines, someplace out there. So I kind of like to say that it's sort of magical, right? So you write your application and you stick it someplace and you just know that it's running in all of these machines, in data centers worldwide. You don't really care where it's running, right? So you don't care that it's actually on your machine, that's in your garage, that's running in your server rack. It's someplace. And you may actually, these may be worldwide, they may be localized to a particular country, but it doesn't matter. And that really influences how you design software. So we'll talk about that a little bit later. So the kind of idea behind cloud computing, right, is this divide and conquer idea. So you're going to divide your workload up between a bunch of different machines. And if one of them happens to fail, you actually don't care. So you actually, you need to be able to define your software such that if one machine completely fails, you just shut it off and don't really care. You can put that workload someplace else. So it's more of, we'll get the next, instead of making, you have one little machine and then you make the machine bigger and then you make your machine even bigger, instead you just add machines to the pool. So if you have 10 different tasks that you want to do, you might put 2 on each machine. If you only have 10 tasks, probably cloud computing is not the right thing. We're talking about millions, right? But if you start kind of, wanting to be successful, if you want your app to rock, you kind of want to start with having this sort of mindset that you're going to have millions of users, hopefully billions of users. So if you start sort of with the right infrastructure from the beginning using cloud computing, then it makes it a lot easier to scale up. So these principles also apply to things like databases. So a typical model, historically was you have a database and you just make the database bigger and then make the database bigger, add some new memory, add some disk to it. Instead, what we're talking about is actually distributing the databases. So you might have some part of your database in different places. So if you're thinking about Google Scale, this means that you don't have your index on one machine. If I could see the machine that would hold all of the internet on one machine, I'd be wildly impressed. So there are sort of 3 different categories where we typically stick sort of cloud services into. So we have infrastructure as a service. That's this bottom tier right here. You guys may have heard of Amazon Web Services. Has anybody used Amazon Web Services? Those kinds of things? Cool. We also have up here Joynet, Rackspace, VMware, and Google Compute Engine, which we'll talk about in a second. So then we have a platform as a service. So platform as a service, maybe I should take one step back. So infrastructure as a service is going to give you sort of the machines that you need in order to run in the cloud. So you're going to get machines in different data centers, but you're still going to have to do a lot of the hard work. So you need to figure out how many machines you want, where you want the machines to go, how you're going to do the load balancing between the various machines, so what traffic is going to go to which machines, but it gives you the machines. In platform as a service, which is what we're going to really focus on today, you're getting a lot of extra features. So it's going to help you with dealing with the different pieces of like how you're going to load balance between the machines, where your machines are. You're not going to worry about those things. So as a software developer, you're going to focus on writing the software, and platform as a service is going to take care of all of those sort of logistics for you. And then finally, software as a service. And this is you guys. So you'd be writing your application, and your software is going to be used maybe by different companies, maybe it's by individual users, or maybe it's Android applications, if you guys went to the Android talk earlier. But it doesn't matter. So there's a lot of examples up here of each of these things. Do you guys have questions so far about this? Yeah? This bottom one, it's actually an I. I hate the typeface. So it's infrastructure as a service. So this is the one where you don't really have the notion, you only have sort of the machines, so you're getting the different machines in different places, but you're going to manage them sort of yourself. So it's sort of advantages and disadvantages of each kind of type. So infrastructure as a service is obviously a lot more flexible. So you can kind of do whatever you want a little bit with them. So you're going to have all these machines. They're going to go in different data centers, maybe with a few restrictions. But for the most part, you can kind of do what you want with the machines. Platform as a service has a little bit more restrictions, but as a benefit, you don't need to worry about sort of those different load balancing things. It's just sort of taking care of it for you. Typically, there are other services involved as well that will help you write your application. So we'll talk about those actually for a bit. Any other questions about this sort of stuff? Okay. So Google has platform as a service and infrastructure as a service. And obviously some software as a service. Most of our apps would be considered software as a service. Think about like Gmail, Calendar, like those are all software as a service. Platform as a service we're going to talk about today. That's Google AppEngine. And we also have infrastructure as a service, and that's Google Compute Engine, which allows you sort of to get these machines in different data centers and manage them a little bit more. So if you're not convinced yet, 40% of all CIOs, that's the chief, what is it? I'm not even sure anymore, but they're usually technology, think that they're going to be using the public cloud in 1 year. This statistic is actually kind of old at this point, but it's still a very stunning number. So Google has a bunch of different pieces here. So there's a bunch of services that we offer in sort of the compute area. So this is the Compute Engine and App Engine. We also have many different storage options, and we'll go in through some of them today, including cloud storage, cloud SQL, cloud data store, and persistent disk. And then we also have a bunch of app services. And these app services are different things that are going to help you build your application. So things like BigQuery, cloud endpoints, caching, task queues, there's mail services, there's a whole long list. So we'll go through a few of those today. So when you build a typical web application, this is what we sort of talked about earlier. You have a bunch of maybe Apache servlets running on different machines. They might interact with different MySQL servlets, and they'll be all over the world. And you need to be able to handle things like hardware failures or traffic spikes. Where are different users? How do you scale? How do you divide your traffic between all these different machines? Instead, with App Engine, sort of a corny tagline here, you're going to not worry about all of those things. Instead, let me see if I got, it sort of simplifies things. So App Engine for a long time was in Labs. We now have 99.9% uptime guarantee. They manage the things for you. So a typical slogan of App Engine would be, we carry the pager so you don't have to. So Google ensures that App Engine is up at all times. Except for, I guess, 0.05%. So it's really, really up all the time. And it makes it significantly easier as an app developer to use these things. So things like App Engine, these things are things that Google has made public because we use them internally. So that's kind of why I'm here today, is I've been using App Engine for several years as part of Google's stack, so software that Google actually uses. Okay. So there's a lot of App Engine users. You might recognize some of these names. Best Buy is a sort of U.S. tech, hardware company. All over the place. Khan Academy. How many people have heard of Khan Academy? Sort of education in the cloud, which is kind of cool. All kinds of stuff. So one particular example we like is the royal wedding. I don't know if it was sort of like a craze here as it was in many other countries, but I know it was kind of crazy in the US. And this page got absolutely ridiculous numbers of views. It looks like 37.7 million page views, and that was hosted on App Engine. So gaming, Angry Birds. Who plays Angry Birds? We're gonna do lots of hands today. Yeah, so things like Angry Birds and the company that makes games like Angry Birds tends to use App Engine for many of its services. So there's a lot of users. And the thing that's sort of special about it is that things like App Engine allow you really to focus on your code. So you don't need to worry about all these other things. So in a model like App Engine is compared to sort of this LAMP stack, you're going to have a series of different front ends. And there's going to talk to different app servers. You may have things that are running your front-end servers, and you also can have things that are running back-end sort of tasks. So you might have a service, for instance, that you want to expose on an App Engine service, or you might have something that's actually running the client HTML page. And all of those can then talk to your data store, which is where your data is going to be living. And there are a couple options there as well. And then they can talk to cache servers, and they can talk to the images APIs and the URL fetch API, and different user sort of APIs across the board. So What AppEngine does, though, is it abstracts all of that away. So you see the big sort of gray boxes. You don't need to worry about sort of what's inside those gray boxes. So as far as you're concerned, you're going to build sort of your one front end, and Google will automatically replicate that code across. You have some settings within AppEngine to say how many instances you might want. So you might want 1 to start out with, and then you might want to scale up. You got a bunch of users, you go up to 5, and you can set that. And then Google will automatically allocate that for you. You guys have questions so far? None. Are you all awake still? It's kind of getting late in the day now. Okay. I'll hope so. No one's answering, so. So there's a lot of services. We'll go through a few of these. And within AppEngine, so these are things that are sort of optional to use. So it's a little plug and play. You get to sort of pick the puzzle pieces that work for your application and your design. But they're there to make your life as a developer easier. So I personally find them really cool. I hate wiring up some of the sort of intricate details of several of these, like sending an email. I think sending an email is just such a common task that, why can't you just automatically send an email update when you do stuff? So AppEngine provides those. So I talked about a few of those, so we'll go into a little bit more detail. So starting with a cloud data store. So usually application developers, one of the first things they think about is what database am I going to use? Cloud data store comes with every AppEngine app automatically. It's NoSQL language. Is anybody familiar with NoSQL? Yeah, so it's a little bit more like key value pairs than SQL. And we'll talk about, we also have a SQL option sort of to compare to data store. It's really low level. It's very easy. When you define your schema, it's very flexible. So I'm more of a Java developer, so you define a Java object that essentially is going to be your object in your data store. You pick some fields, name them, they get a value, and then you can dynamically add to that very, very easily. So if you want to just add a new field in there, you just go ahead and add that. It's very, very easy. This is replicated against all of the different instances that you have. So it's resilient to failures. If one of the data store center gets who knows what happens, your data is still safe. It's in another data store and it gets replicated. In fact, it's probably in several locations worldwide. Awesome. So you have different row keys and value keys, and then this then gets sharded across many different machines. And it's replicated, and everything is sort of happy and awesome. If you wanted to query this, you can do a full text query or query for a particular field. So in this case, we're querying, this is just an example query where you might query for something like greeting, and then filter by a particular property, to equal, something. So if you wanted to say, let's say it's user data, so you'd say user is Sonny, and I'm looking for Sonny's data where it has something to do with Google. So we search for Google. And then we can actually add a sort as well. This adds a sort for date. So it's pretty easy language to sort of get used to. Any questions? It's much more fun when everybody asks questions. So we'll see how this goes. Okay. So you have a few other options as well for storage, and one of the more popular ones is Google SQL. This is something that actually you have a SQL database that can be shared against multiple AppEngine apps even. So you may have 2 different AppEngine apps that actually access the same SQL storage, or you can have one, it's fine. It's normal SQL, so if you've used a MySQL database in the past, it's the same kind of syntax, and it's really easy to set up with your AppEngine app. We have a bunch of other services as well, including things like Google Translate. So if you wanted to automatically internationalize your application and translate your text into different languages, you can do that. I think Google Translate, I'm not even sure how many languages we're up to worldwide, but it's quite a few. I know that it works with Turkish. I've tried it. We have things like BigQuery. So if you want to do large-scale sort of query analysis, you can do that. This is also SQL-like. So lots of stuff that you can do there. Prediction API, this is machine learning. So it's Google's technologies for machine learning, except it's available publicly, and it's really cool. So if you want to do some machine learning analysis of your data, the prediction API is sort of where you want to look for that. And then application identity. So this is a really important one. And this allows there's two different types of identity that your application needs to care about. And the first is sort of obvious. Most apps want to know who their users are so that they can kind of customize the experience based on the user. And this, you can automatically have Google handle their credentials for this. So you just log in, and then the app identity service will provide your application with what credentials sort of the user has. This is important, so if you want to call another API, you already now have the credentials for your user, which means that things like if you want to use OAuth is very easy to use from AppEngine, so you can call different APIs, and that sort of all just sort of works. Then you also have an app identity. So if your application itself needs to call out to other APIs, it needs something to identify itself. And that's where app identity comes in. So it's when your application needs to call a particular service, it will identify itself as sort of, I am AppEngine app, XYZ, and the other app can recognize that that is in fact your app. So we talked a little bit about, if you want it, you have an identity and you want to call out to these other services, you need your own identity. But what if people are going to call into your app? So this is the case of where Google Cloud endpoints are useful. So in Google Cloud endpoints, the idea is that you should be able to make a service that other applications can call into really, really easily. So this supports, different mobile apps. You can use it directly with your browser code. Whatever you want. So this is typical for REST APIs, REST style APIs, but you can add your own custom methods if you want. It's totally fine. And you just basically define what your API looks like, and you can annotate that to define what URLs you want them to be accessible on, what operations those things are accessible by, and so forth. It's pretty awesome. There's a little tutorial. So if you're interested in sort of creating your own API, I highly recommend looking at that. If you're thinking about sort of playing with APIs, it's a really good way of getting started with an API and sort of learning how you want to define something like that. Do you have questions? Awesome. No, everybody's very quiet. I know it's warm. So URL fetch, this is the way that you would access somebody else's API. This gives you easy access to other URLs, other services. You can do things synchronously, asynchronously, whatever you want. Images, so if you want to resize images, flip images, as a typical UI developer, I find doing things like this absolutely painful, and it will do this automatically. So if you want to start messing with the AppEngine icon, you can do whatever you want. You see all the different sort of things that happen. I'm feeling lucky to see if you want to be just magically transform your images. Whatever works. So, and then things like MapReduce. Does anybody know what MapReduce is? Does anybody want to try and explain MapReduce? No, no one wants to try. You sure? What? Absolutely. So let me repeat that. MapReduce is a technology that I think Google actually wrote the paper on, but it's very popular now. It's an algorithm for distributing workload between multiple machines and then aggregating that information at the end. So sort of mapping, you're going to map the data from, to multiple machines, and then you're going to do a reduction stage, and that reduction stage is where you're actually going to go ahead and analyze and aggregate that data back together. So it's typically used for wide-scale data processing. So if you want to do a bunch of, what is it, for Google, it's all, finding a bunch of different links and figuring out what links go to which pages, and you want to distribute that workload between a bunch of different machines, and then at the end figure out where those links are actually going. This is something that MapReduce is really, really good for. So if you want to do wide-scale data analysis, I would definitely look into something like this. There's an API that's sort of baked into AppEngine, so if you want to analyze your data, because you have a lot of data that you've now stored in your app, MapReduce is sort of the thing to do that. Memcache. So Memcache is, you have your data store, but that's going to be stored on disk. And if you want to have something that's really fast to access locally, Memcache is sort of the option. So that's a caching that's sort of built into AppEngine apps. One example of that is, let's say you want to cache some basic user information. You can do that, and then there's fast access. So this is showing you that it's 2 milliseconds to read from Memcache, whereas it might be 20 milliseconds to read actually from data store. So if there's pieces of data that your application is going to be accessing frequently, it's great to put that into Memcache. There is sort of a downside to that, is that Memcache is localized to a particular instance. So your particular instance is going to be very, very fast for fetching that data. Whereas data store is replicated across all of the machines. So there's no guarantee that your data is actually in that Memcache. So a typical sort of usage model would be that you put some data into Memcache, check if it's there. If it's there, then great, everything is really fast. If not, then you fall back to data store, cache that into Memcache, and can return to the user. Yeah. Is there a microphone?
In the Memcache, the data is located, right? Not the index of the data.
So it's just the data. So it's key value pairs again. So you can put it's freeform, whatever you want to put in there, it's fine. What it means though is that, so you're going to have a bunch of different instances, and they're going to be worldwide. This is sort of that cloud idea. And typically a user will go to the closest instance to them. So it will be localized to that instance, and it won't be replicated to all of the other instances.
Is there a way to put the index only in memory? So if you can put only the index of the data in memory, we can access the data in the disk easily, more faster.
Sure.
So is there an in-memory caching?
I'm not sure I know. So, yeah.
Because the data that we can access from memory will be less comparing to the disk area.
Sure, yeah. So typically what I've used Memcache in the past for is just caching data that's already in data store. And so you'd fall back on that. So you can put whatever you want in Memcache. I'm not sure that it's baked in to do anything like that. But if you wanted to use Memcache, you can use it sort of however you want. It's pretty free form. There are other features. I'm going to go through these really quickly, so just jump in if you want to hear more about any of them. Things like warm-up requests. So this is a typical, if you want one thing to happen when an instance spins up automatically, potentially you have like a set of data that needs to be automatically stored or loaded into Memcache, for instance, or something else. This is where warm-up requests are really useful. This is all specified actually within your there's a configuration file that you use for AppEngine, and you can just specify what you want to happen on warm-up. And you can actually specify other things like what error pages you want to show up on particular errors, and these things sort of just happen for you. So this is the error pages sort of example, and this is the HTML that you might want to put in, sorry, it's more XML, that you would want to put into your configuration file. So you can try Google AppEngine actually today without downloading anything on your machine. If you want to actually develop long term, you'll need to download the SDK and different developer tools. But if you want to just try it out without anything, you can actually go to the Cloud Playground. That's cloud-playground@appspot.com. And you can try out sort of building an app and looking at how that would deploy. So from there, there's a bunch of developer tools to make AppEngine development just a little bit easier. Things like Google plugin for Eclipse, which I don't know if you've done any sort of Google development before, but this provides a lot of tools. This is what Google developers use with Eclipse internally as well, so it's very powerful. And this automatically can create a new AppEngine project for you. It will create some of the sort of basic boilerplate that you need, including configuration files. You have multiple choices of different languages you want to use with AppEngine, and it'll automatically sort of create the right thing. It also provides then utilities that you can automatically go ahead and deploy directly from Eclipse. So it has sort of a lot of the tools you want to do as a application developer. The administration console, so this is just a screenshot of what this looks like. So once you have your AppEngine app, you pick your name, you register it, and so then you have myapp.appspot.com, and then inside there you can actually take a look. And this will show you what versions of your app you have. You get to choose how many machines you might want, location, how you want authentication to work. Do you want to mandate authentication, or do you want to allow anybody to take a look? You can change all kinds of various settings. You can look at the logs. You can look at how much query traffic you're getting. All of those great things that you might want as a application developer. So when you push a typical sort of use case, you go ahead and do a new release of your application. You go ahead and push. You can do that directly from Eclipse. You hit deploy, and then you can go in here and you can take a look at if you're new. So you can now set that app as to be the default. If you want to test that first, you can go ahead and test that. There's a URL right in here to test out your new application before you make it go live. Make sure that nothing was really broken there, and then you can go ahead and set that as the default app. As an application developer, this is super useful. It gives you, a chance to go ahead. Let's say that something goes wrong. You can also automatically roll back your application to a previous version directly from in here. So it's pretty awesome. If you're not convinced yet, this is sort of the trajectory of AppEngine by the numbers. We sort of cut off at 2011 because it just kept growing. So it's quite scaled up at this point. So, and here's some basic numbers. Again, these are a little bit old, but 300,000 plus active developers, 3 million active applications, and half of the world internet addresses actually touch it. So it's quite a few. And some more stats. You guys are curious. It's quite a few. Data store requests, that would be reads to specifically data store, not to the other databases that are supported. And so for everybody attending today, we actually have a special starter pack code. This gives you $1,000 on Compute Engine and $1,000 on Google AppEngine, which are quota priced. So you can get started for free, but this will give you already $1,000 just to try it out, of quota. So if you want to try out AppEngine, I'd recommend this. This is the URL. It's the goop.gl 4THRT0, and then this code you need to get that free quota. So if you go to that URL and enter that code, you will get that sort of $1,000 free of quota for those. So, do you guys have questions? Sure.
More traditional methods like programming a PHP web server service, which would cost a lot cheaper. So I was wondering, how risky would it be to proceed like that? I mean, maybe after your project becomes a hit and becomes famous, you can just start coding in cloud. Is it not possible?
No, it's absolutely possible. So, make a couple of arguments. So, yeah, as an application developer, you sort of have these sort of the traditional method or going into the cloud. So the question is sort of which would you want to do? I would actually argue that starting with AppEngine would be cheaper probably than doing a PHP traditional server because it's free to actually get started. So the second thing as well is something like AppEngine, I actually didn't include this, but all of your data, so Google has a policy of data liberation. So any of your data and your configuration and things that you're creating for AppEngine, you can move easily to another server. So if you want to use like a PHP front end or whatever, like that's a very typical model actually doing on AppEngine. You'll write your servlet code in Java or Python or whatever your choice is. You can write it in, I think it's directly supported with Go, Java, and Python, but there's other languages. So sort of you can pick your language of choice. The nice thing about AppEngine is that you can get that free hosting from the beginning. It's only as you're scaling up that you really have application costs. So when your application becomes popular, yes, we charge, but it's on a per use sort of basis. So it scales up as you go.
Thank you.
Yeah. So my recommendation in general, and part of why I'm talking now, is that if you start kind of with the idea of cloud in mind, when your application is popular, you're kind of ready for it. If you start with sort of the traditional model of buying machines, as soon as you get enough developers that you now need another server, you need to suddenly care about how to replicate your data. You need to make sure that your writes are resilient. So if you write to one machine and then that machine completely dies, did the user's data get lost? And things like that. Whereas if you start with sort of this cloud mindset in mind from the beginning, you're ready, right? So the nice thing about things like AppEngine and other sort of platform as a service is that you're ready to scale up, but you can start small. Is there more questions? Questions about AppEngine? Questions about Google in general? So. Nothing? Interview tips. Why don't you come up and we can, yeah. Are people looking to start interviewing for full-time jobs soon, or all of you have jobs already lined up? Do you guys have questions about interviewing jobs? Yeah. Sure. So
I was wondering how hard it is to get accepted from a country outside of states to Google headquarters, because you would need a H-1B visa sponsorship, and I applied many companies like Intel, etc., and I literally have won grand prize awards from them. But even though many accomplishments directly from them, they rarely respond to your application. I was wondering, do they just ignore applications outside of states?
no. So I can try to answer that. So I'm not a lawyer, so I can't answer the sort of the very, very specifics of it. But as I said, I work in Germany, so I also had to go through sort of the visa process to work there. So the answer is that it's not super trivial, but it happens very, very often. So I know I can only really speak for Google, but many of our employees in different offices do have to go through a visa process in order to work in those particular offices. We absolutely hire people who will require a visa. We really just want the best engineers we can get, and we really don't care where they're from. So we'd really just prefer that we have the good engineers. The one sort of caveat to that is certainly there are some restrictions. What I have heard periodically is that sometimes they will have choose offices based on where we can base somebody with sort of the easier visa. So some countries have easier sort of visa restrictions than others for exchanges between other countries. So maybe it's like a whole map, and I'm not a lawyer, so I can't possibly speak to the visa process. But
and we also can't speak to Intel and other companies.
Yeah, so I have no idea what's going on there. So
it was a more general experience. It happened with other companies too. So I just give an example.
Yeah. The good news, I don't know if you guys know this or not, but we do actually have an Istanbul office for Google. I believe it's not engineering right now, I think. So if you're looking for an engineering position, there aren't in Istanbul currently, but there are several other countries, and certainly Turkish employees at them as well, at other locations. So. Yeah, there you go. So in New York, there's at least one.
I have one more question, but it's a bit out of topic. So I was wondering when Google will support merchant accounts for Turkey to put paid apps on Google Play Store. If you have any information about it.
That is a good question. I was on commerce, and if I'd still been on commerce, maybe I would have a good answer for you. But that's definitely something I'm sure the commerce team is working very hard on to launch in as many new countries as possible for obvious reasons.
Thank you.
And we had a question over there.
Yep. We can also take questions as well, being women engineers, being whatever you want. We're both very active and actually in our local women's groups as well.
I was going to ask, I'm a computer engineering major from 4 years ago, and I visited Google Ireland in 2007 through a Googler who works there, and I was really interested in working Google, but I applied maybe like 5 times, but I never got a response. And when I saw the people who were hired by Google from Turkey, I don't mean you, but they seemed to me like just very ambitious people, but in a bad manner, and they are not very creative people, in my opinion. And I'm wondering, what am I missing, I'm really ambitious, and I really want to work for Google. I really wanted to, but then I stopped applying. It was 4 years ago.
We're sorry to hear that you stopped applying. One thing just to be aware of, yeah. And it's it's absolutely, it's a question we probably have both gotten many, many times, is I've applied all these times and I never hear back. And the answer is, honestly, don't give up on us. Part of it is that we are sort of moving internationally very, very quickly. And we also do get a very high load of resumes submitted. So, sometimes things, honestly, we look at every resume that's coming in, but it's sometimes hard. The trick, making your resume awesome is absolutely, and finding things that make you stand out and getting those onto your resume, I think, is really important. I'm also sorry to hear that the people who were hired weren't very creative or awesome enough. So I'm not sure I can comment on that situation specifically, but.
I just want to add that Google is not the end-all, be-all. I work there, but I'm still allowed to say this. I think being at Google is about, or wanting to be at Google is about having a certain spirit about the way you approach life. And it's about being open and eager to take on challenges. It's about being collaborative and respectful. Unfortunately, we don't always do the best job of picking people who are collaborative and respectful. So, it's a flawed system, as it is everywhere. But it's important to keep in mind that if you are a huge fan of Google, we love you. It's really good that you're a huge fan, and we need people like you. But you don't have to be at Google or any particular company to be really excited and make awesome things happen. So I think, what was it? Viber, was it? Or what was it that just WhatsApp? Yes, WhatsApp recently got bought out by Facebook for a lot of money, ridiculous amounts. The guy, one of the founders, was rejected from Facebook when he interviewed with Facebook. So these are by no means, reflections on you. So I would say go forth and come up with interesting ideas, launch things, have fun, and if Google is worthwhile, it'll happen. If not, not. Don't worry about it. Yeah, exactly. Questions? Okay. No questions.
Sorry, I want to ask that I have to do internship in the summer to graduation, but I asked many companies, they said no. Actually, I am a very bad coder. I have no idea about coding, and I'm a computer engineering student. So, but I can speak 3 languages. So can I come to Google? I have to do this for graduation.
We have a bunch of roles. If any of them are applicable, then absolutely apply, I think would be my best answer. Yeah. So if you go to google.com/jobs, for students, it's google.com/students/jobs. You'll see a whole listing of what kinds of internships or full-time positions we have available worldwide, and descriptions of what requirements there are, and so forth. So internship, I think, depending on where in the world it is, a lot of the interviews are happening sort of right around now, actually. So yeah, I would.
And also make up your own internship. Yes, come up with a project, work on it, and add it to your resume. Have the code open source and available on GitHub so you can prove that you actually wrote it. Have your demo on appspot.com so you can prove that it really works, and you're done.
Yep. There's also scholarships as well that are available for doing things like that. So you can even get paid to do that.
Summer of Code.
Yeah.
Right?
So do you want to talk about Summer of Code?
Sure. I think I don't have full details on it, but you get paid to contribute to open source projects if you are in college, and Google will pay you money for it. And it's something that happens over the summer. It's called Google Summer of Code. You should look it up. Yeah. One more question.
Okay, there is this internship of Google. It's for students in Europe. It's called STEP.
Yep.
Okay, is it open for students in Turkey?
Yes.
More or less international students in Turkey.
I believe it's open for students worldwide. There's a similar program. I know in it's our EMEA org, which Turkey is a part of. So there's a sort of similar program as well that's also available. So probably the more local one would be I would assume better, but you can apply to either program. So all of those things should be on google.com/student/jobs, and you should see that. So we have a couple, if you guys are not familiar with the program, we have one program. It tends to be more for people earlier in their university career. And it's to sort of get, more into sort of a first internship kind of experience. Then we have a full internship experience. And both of these programs you can apply to at any, sort of point. That's fine, but there's the full internship, and then there's this program. So.
Okay. And there's one more thing concerning the GSA program, Google Student Ambassador.
Okay. Yes.
Yeah. For the, Turkey, does it follow to the Europe region or MENA region in this program?
I don't know. I was actually a Google Student Ambassador, so but I did it in the U.S., so I'm not sure what program it is. If there's anybody else from Google who might be able to answer that here, there's a few others. Okay.
Any more questions? Question there?
Okay, I think we're getting told we're out of time, but we'll hang out if you guys have more questions.
We can answer the questions.
We'll answer out in the hallway. So
okay, cool.
Thanks.